For thousands of years, it's been one of the world's great mysteries. Just how were the pyramids built so deep in the Egyptian desert?
Ask Grok who built the Great Pyramid, and you'll probably hear the same explanation that's been taught in classrooms for generations. But a small group of researchers decided to approach the mystery differently. Instead of asking AI for opinions, they fed it every available survey, engineering measurement, astronomical alignment, and structural tolerance ever recorded for the Great Pyramid of Giza. Then they gave it one simple instruction: forget the accepted theories and examine only the raw data. The response wasn't the name of an unknown civilization or a forgotten date. Instead, Grok uncovered a hidden mathematical pattern buried within the pyramid's proportions, angles, and astonishing precision, something that the traditional explanation struggles to account for. Nobody expected artificial intelligence to find it, and the deeper the analysis went, the further it moved beyond the limits of conventional history. Before we reveal what those incredible patterns actually mean, take a quick second to subscribe and help us reach our goal of 1,000 subscribers. If you're fascinated by ancient mysteries, hidden history, and discoveries that challenge everything we thought we knew, you're in the right place, and you won't want to miss what's coming next. That unexpected discovery inspired a bold experiment. Rather than relying on centuries of assumptions, a few people turned to one of humanity's newest inventions to investigate one of its oldest mysteries. They asked artificial intelligence to evaluate the evidence without bias, without protecting established beliefs, and without worrying about academic consensus. What emerged wasn't just another theory. It was a conclusion that challenges the story most of us have accepted for years. But before we explore why that conclusion matters, we first need to understand the official explanation exactly as it has been presented. Standing on the Giza Plateau outside Cairo is a monument that almost defies comprehension. The Great Pyramid isn't merely an ancient building. By every practical measure, it feels like something that shouldn't have been possible. Nearly 2.3 million stone blocks, each weighing anywhere from 2 to 15 tons, were carefully assembled into a structure that originally reached 481 feet into the sky. Many of those stones fit together with such extraordinary precision that even today, in certain places, it's difficult to slide a sheet of paper between them. For almost 4,000 years, it remained the tallest structure ever built by human hands. Even now, standing at its base, it feels less like a man-made building and more like a mountain that somehow grew naturally from the desert itself. According to mainstream archaeology, the explanation is straightforward. Around 2560 BCE, during Egypt's 4th dynasty, Pharaoh Khufu commissioned the pyramid as his royal tomb. Over the next 2 decades, tens of thousands of skilled workers, not slaves, as popular culture often suggests, organized into professional labor crews. They quarried limestone directly from the Giza Plateau, transported finer stone along the Nile, dragged enormous blocks across wet sand using wooden sledges, and gradually raised them into place with ropes, levers, and remarkable determination. Their tools were surprisingly simple: copper chisels, stone hammers, wooden mallets, plumb lines, measuring cords, wooden squares, and shallow water channels used to establish level surfaces. The remarkable part is that this account isn't based on imagination. Archaeologists have uncovered entire worker settlements, complete with bakeries, breweries, living quarters, and animal remains. They discovered skeletons showing healed fractures, proving injured workers received medical care. Ancient papyrus records document the transportation of stone, while hidden construction marks and crew names painted in red ochre still survive inside the pyramid. Teams proudly called themselves names like the Friends of Khufu, leaving behind unmistakable evidence that real people built this incredible monument. Imagine the scene at sunset. Fresh bread baking, workers sharing beer after exhausting days, healers treating injuries, and crews proudly celebrating the project they believed would outlive them all. For that reason, mainstream archaeology presents a strong and evidence-based explanation for who built the pyramids and how such an enormous workforce was organized. Yet despite all of that evidence, one question has never been fully answered. The accepted story explains the labor, the logistics, and the transportation remarkably well, but it struggles when it comes to something much more difficult to explain: precision. We know who moved the stones, but how are those stones cut, aligned, leveled, and positioned with an accuracy that in certain measurable ways rivals what modern engineers achieve using lasers, satellite surveying, and advanced machinery? That unresolved gap became the very question researchers asked Grok to investigate. Before we dive into what those measurements reveal next, make sure you subscribe. Not for me, but because the next discovery may completely change the way you think about the Great Pyramid forever. And that was only the first measurement. There were still 4 more waiting to be analyzed, and each one created even bigger problems for the conventional explanation than the one before it. If the investigation kept following this trail, it would eventually point toward a place almost nobody has seriously examined. That's why this story becomes more fascinating with every new discovery. The question given to Grok was intentionally narrow. It wasn't asked who built the pyramid or why it was built. Instead, the AI was given a much simpler challenge, based only on the tools historians believe the builders possessed: a stretched measuring cord, a water-filled leveling trench, a wooden square, and basic hand tools. How likely was it that an ancient workforce could produce a foundation this incredibly flat across such an enormous distance while maintaining the same accuracy on all 4 sides? Grok didn't answer with speculation or theories. It answered with probability. According to its analysis, achieving this level of precision using only those traditional methods wasn't impossible, but it was statistically highly improbable. That distinction matters. Every small variable should have introduced errors. A rope stretches under heat. Water shifts slightly with changing temperatures. Workers become exhausted. Tiny mistakes naturally accumulate over time. Under normal conditions, those imperfections should compound into visible inaccuracies. Yet the Great Pyramid shows almost none of them. Instead of gradually drifting out of alignment, the builders repeatedly produced results so precise that even modern engineers would struggle to reproduce them consistently without advanced equipment. What makes that conclusion even more remarkable is that modern construction rarely demands this level of perfection. When engineers pour the concrete foundations for today's skyscrapers, the acceptable tolerances are generally far less demanding than those measured beneath the Great Pyramid. Modern buildings simply don't require such extreme accuracy to remain safe and functional. Elevators still operate, structures remain stable, and no one notices tiny variations in level. Yet thousands of years ago, someone invested enormous time and effort to produce a foundation that exceeded what most modern projects would even consider necessary. That naturally raises another question. Why go so far beyond what was required? Every additional fraction of precision costs time, labor, experience, and resources. It means more measuring, more adjustments, more rejected materials, and far greater attention to detail. For an ordinary tomb, such extraordinary accuracy serves no obvious purpose. The people buried inside would never know the difference. So why dedicate countless extra hours to achieving a standard that appears completely unnecessary. Either the builders possessed construction methods so refined that this accuracy became routine, or the precision itself was the true objective. Grok didn't choose between those possibilities. It simply recorded the anomaly and continued examining the data. The next measurement turned out to be even more difficult to explain. After studying the pyramid's foundation, Grok shifted its attention toward the orientation of the entire structure. Once again, the numbers refused to behave the way conventional expectations suggested they should. The Great Pyramid isn't merely positioned in the desert, it is aligned with astonishing accuracy. Its four sides point almost perfectly toward true north, south, east, and west. The margin of error isn't measured in full degrees, but in only a few arc minutes. Since a single degree contains 60 arc minutes and the entire horizon spans over 21,000 arc minutes, the builders missed perfect north by only a tiny fraction that is practically impossible to detect without precision instruments. This isn't something that can be achieved through estimation or experience alone. You cannot simply look toward the horizon and instinctively determine true north with that level of accuracy. Either someone understood exactly how to measure it, or the result would be little more than an unbelievable coincidence. Grok wasn't interested in coincidence. It focused on the measurable evidence. The challenge becomes even greater when you remember that true north isn't the same as magnetic north. A compass points toward Earth's magnetic pole, which constantly shifts over time. True north, however, follows Earth's rotational axis, an invisible point that cannot be seen directly. Finding it requires careful observation of the night sky, tracking the movement of stars for countless hours, identifying the precise celestial rotation point, and then transferring that invisible direction onto the ground with extraordinary accuracy. From there, that line must remain perfectly consistent across a construction site stretching more than 230 meters without drifting even slightly. Picture an observer standing on the Giza Plateau night after night, beneath a sky full of moving stars, patiently recording their positions until the exact celestial reference point reveals itself. Then imagine converting that invisible location into a straight construction line scratched into the sand, knowing that even the slightest mistake would throw the orientation of the entire pyramid off course. Yet somehow, the finished monument achieved a level of alignment that rivals what modern surveyors accomplish using precision instruments, satellite positioning systems, and technologies developed more than 4,000 years later. That naturally led Grok to another unavoidable question. If the Great Pyramid truly served only as a royal tomb, why was this extraordinary astronomical precision necessary in the first place? A burial chamber doesn't require nearly perfect alignment with Earth's geographic axis. Most monuments throughout history never demanded anything close to this level of accuracy. So why did the builders consider it so important here? That question remained unanswered, but it became impossible to ignore. If the Great Pyramid was simply built to honor a deceased king, then why was such extraordinary accuracy necessary? A royal tomb doesn't require alignment that rivals or even exceeds the precision achieved by modern surveyors. No visitor standing outside could ever notice that level of perfection with the naked eye, and no ancient ceremony depended on it. The precision goes far beyond any practical purpose we can identify. It surpasses every reasonable explanation. And when the quality of the engineering exceeds the actual need by such an enormous margin, an uncomfortable possibility begins to emerge. What if the precision wasn't serving the monument? What if the precision was the monument? What if perfect alignment wasn't a method used during construction, but the very message the builders intended to leave behind. Imagine someone standing on the cold desert plateau thousands of years ago, carefully directing an enormous mountain of stone toward the exact center of the heavens, knowing that almost no one alive at the time would ever understand why. Perhaps the builders expected that only someone thousands of years later, equipped with better tools and asking better questions, would finally recognize what they had done. The next measurement seems to push that mystery even further, and surprisingly, it comes from one of the simplest geometric relationships imaginable. Consider the perimeter of the pyramid's base. Walk around all four sides and calculate the total distance. Then compare that number to the pyramid's original height before its missing capstone disappeared. Divide the perimeter by twice the height, and something unexpected appears. Instead of producing an ordinary ratio, the result comes astonishingly close to the mathematical constant known as pi. That endless, irrational number, 3.14159, and continuing forever, is the foundation of every circle ever measured. Somehow, a monument built almost entirely from squares, triangles, and straight lines seems to contain within its proportions the geometry of a perfect circle. Even more remarkable, the agreement isn't approximate. The value falls within a tiny fraction of the true number, close enough that many engineers find it difficult to dismiss as coincidence. Supporters of the traditional explanation do offer an alternative interpretation, and it's a reasonable one. Some researchers suggest that the appearance of pi may simply be a byproduct of the measuring methods used by the ancient Egyptians. If horizontal distances were measured using rolling drums or wheels, while vertical dimensions were recorded in cubits, then certain geometric relationships involving circles could naturally emerge without the builders consciously understanding the mathematics behind them. In that scenario, pi wouldn't have been intentionally designed into the structure. It would simply appear as an accidental consequence of the measurement system. It's an elegant explanation, and Grok didn't ignore it. Instead, it compared that possibility against every available dimension throughout the pyramid. That's where the analysis became much more interesting. The ratio involving pi wasn't the only unusual mathematical relationship appearing within the structure. Another pattern emerged beside it, one that is considerably harder to explain away. Unlike pi, which naturally appears whenever circles are involved, this second number doesn't arise through ordinary measurement techniques. It is the mathematical proportion known today as the golden ratio, or phi, approximately equal to 1.618. This remarkable constant appears throughout nature, from the spirals of seashells and galaxies to branching trees and the arrangement of sunflower seeds. Humans often associate it with balance and beauty, yet according to recorded history, the golden ratio wasn't formally described until Greek mathematicians documented it more than 2,000 years after the Great Pyramid had already been completed. That enormous gap creates an unsettling question. If historical records are correct, then the concept of phi shouldn't have existed when the pyramid was built. Yet measurements of the monument repeatedly reveal proportions that closely resemble the golden ratio, particularly in the relationship between its height, base, and the slope of its massive triangular faces. Unlike pi, there is no simple measuring wheel or construction technique that naturally introduces phi into architectural dimensions by accident. It doesn't casually appear through ordinary building practices. If the ratio truly exists within the pyramid's design, many argue it would have required deliberate planning rather than fortunate coincidence. Finding one mathematical coincidence might be dismissed as chance. Discovering multiple precise relationships woven throughout the same structure becomes much more difficult to ignore. At that point, the proportions begin to resemble something almost intentional, as though the builders embedded their understanding directly into the geometry instead of writing it on the walls. Walk alongside the pyramid today, and you won't find inscriptions explaining these numbers. There are no carved formulas, no diagrams, and no declaration from its architects claiming they understood advanced mathematics. The message, if there is one, isn't written in words at all. It's written in proportion. Hidden silently within millions of tons of stone, it waited thousands of years for someone equipped with modern measuring tools, and perhaps a different way of thinking, to notice it. If that was intentional, it may be one of the most extraordinary messages ever left behind. The final pattern Grok examined was the most controversial of all. Some researchers argue that when the Great Pyramid's original dimensions are multiplied by 43,200, they closely match the Earth's polar radius and equatorial circumference. Supporters believe this suggests the pyramid was designed as a scaled representation of the planet itself. Skeptics, however, argue these similarities could simply be the result of selective mathematics and coincidence. Grok didn't treat this as proof. It treated it as another intriguing possibility. What mattered wasn't any single measurement, but the entire collection of them. The remarkably level foundation, the near-perfect alignment to true north, the mathematical relationships resembling pi and phi, and even the debated Earth-scale proportions all pointed in the same direction. Any one of these findings could be explained away individually, but together they formed a pattern that was much harder to dismiss. Even then, Grok never claimed to know who built the pyramids. It didn't conclude that aliens were responsible, nor did it endorse lost civilizations as fact. Instead, it reached a far more cautious conclusion. Based purely on the available measurements and engineering data, the conventional explanation appears incomplete. It may explain the workforce and construction process, but it doesn't fully account for the extraordinary precision embedded throughout the monument. That doesn't rewrite history, but it does leave an important question unanswered. If the accepted story cannot explain every measurable detail, then perhaps there is still something significant about the Great Pyramid that humanity has yet to understand. After more than 4,500 years, the monument continues to stand in silence, offering no explanations, only evidence. And until that evidence is fully understood, the mystery remains very much alive. Before you go, if you enjoy exploring history's biggest mysteries backed by real evidence and fascinating discoveries, make sure to subscribe and turn on notifications. We're getting closer to uncovering secrets that could completely change the way we see the ancient world, and you won't want to miss what's coming next.